We're going to talk about parallel lines that are cut by a transversal or intersected by a transversal. So just a reminder, parallel lines are coplanar lines that do not intersect. So a transversal, this is sort of the new part, is a line that intersects with two or more lines. So we have an image here, and it tells us that these two lines here in blue are parallel. And remember, we could put little arrows on them to mark that. And our transversal in this problem is this red line, line L, that is intersecting both of these lines. Now, when we do that, we create 8 different angles. So I'm not sure why they're labeled 2 through 11. We could label them 1 through 8, but it creates 8 different angles, right? 4 up here, 4 up here, and 4 down here. And when we have this special case where these two lines are parallel, we get some really nice angle relationships. 2 of these relationships we already know. So we know angle 3 and angle 4. Those are my 2 angles up here. That's an angle relationship we've already seen, and those are a linear pair, which means that they are both supplementary and adjacent, right? So they're supplements of each other, and so they add up to 180 degrees, and they're adjacent. So they're next to each other, they share a side. And there are quite a few linear pairs, right? 2 and 5 would be a linear pair. 7 and 9, we have quite a few in here. And that's a very useful thing to know because supplementary helps us find angle measurements. The next one we know, for an example, is 10 and 7. So these two angles, they're directly across from each other. They're formed by two lines intersecting, and we know these as vertical angles. Okay, now the important thing about vertical angles is that they are congruent. That's very interesting to us because that means their measurements are equal. Okay, now we're going to talk about a couple of other angle relationships, and for that we're going to need some additional vocabulary. So we're going to need to talk about the interior and the exterior of this figure. So the interior is going to be what is in between the two parallel lines, and the exterior is going to be out here, outside the two parallel lines. Okay, so that's what we're going to refer to as our interior and our exterior. We also want to talk about the words alternate, or the word alternate. So alternate sometimes is a word we use that has a similar meaning to opposite. And in this case, we're going to be talking about alternate sides. So if we look at this transversal, we kind of have a left or a bottom side, and then a right or a top side, depending on how you're looking at it. And when we have two things that are on one side, one's on one side and one's on the other, we call that alternate. Okay, so the next angle relationships are described using those words, or most of them are using those words. Are they alternate? Are they interior? Are they exterior? And there's going to be a couple other things going on here. So I'm going to clean up this picture a little bit so that we can draw on it a little bit more. Okay, so the first angle relationship we have is something like 2 and 7 here. Okay, 2 and 7. So I'm going to erase this. Okay, so 2 and 7, first thing I notice is that they are alternate angles. One's on kind of the left side, one's on the right. So I'm going to call these alternate. And then I also notice that they're both on the inside, what we would call the interior. So we refer to these as alternate interior angles. And the important thing to note about these angles is that when the two lines cut by the transversal are parallel, these two angles will be congruent. Okay, alternate interior angles will always be congruent. So you can notice that they're both acute, and they're going to go ahead and be congruent to each other. We have another set of alternate interior angles, that's 5 and 7. They're both obtuse, and they're going to be congruent to each other. Okay, next up, we're going to take a look at 3 and 9. So again, these are on alternate sides, but this time they're on the exterior. Okay, they're two obtuse angles, and again, we're going to have that same relationship where they're going to be congruent. In general, everything in here in parallel lines cut by a transversal is going to have one of two relationships. They're either going to be congruent to each other or they're going to be supplements of each other. So we've seen a lot of congruent and we've only seen one supplement so far. So another pair of alternate exterior angles might be 4 and 10. They're both acute, and in this special case they are congruent to each other. Okay. So let's take a look at 5 and 7. So this is a little bit different. This time they're not alternate. This time they're on the same side. So we can say same side, or another word we sometimes use is consecutive, right? You might have seen that word when referring to consecutive integers. So it just means they're kind of next to each other, is sort of what that means, but one right after the other. Same side is a little bit more descriptive for them. They're on the same side and they are on the interior. Okay, same side and they're on the interior. Now what you might note is that one of these angles in the image is obtuse and one of these angles is acute. So they're not going to be congruent. That's impossible for an obtuse angle and an acute angle to be congruent to each other. So instead, they're going to have that supplementary relationship, right? That's our adding up to 180 degrees. These guys are going to be supplementary. Okay. Now, similarly, we have 4 and 9. Now, the only difference here, they're on the same side, but this time they're on the exterior. So we call these same side or consecutive exterior angles. Again, we have one acute, one obtuse, so they are also supplementary. So adding up to 180 degrees. Last relationship we're going to look at is a relationship like angles 4 and 7. Okay, now they are on the same side, but one is in the exterior and one is on the interior of this figure. But what we want to note is that they're in what we are going to say is the same position. So if we almost think about this as a clock, you know, or a coordinate grid is kind of a good way to think of it. Maybe this is 1, 2, 3, 4, and the other one mimics that. 1, 2, 3, 4, going counterclockwise there. They're both in position 1, all right? They're in the same position, they're just in a different set of the 4 angles created in this figure. We call these corresponding. These are corresponding angles. So they're in corresponding positions on the figure, and corresponding angles are always congruent. So those are our major angle relationships, and we're going to use those relationships in order to solve some problems and figure out some additional angle measurements. Okay, so when we're solving a problem, the main thing to find is the two angles that you're trying to use to identify either a variable or a measurement. So this asks us to find the value of all numbered angles, and we're just going to list it on the figure. But first I'm going to note that we're starting with these two angles here. And I'm going to look at them and I'm going to try to decide what is their relationship. Okay, what is their relationship? And as of right now, these two don't really have a relationship. They're on alternate sides. One's on the exterior, one's on the interior, but they're not corresponding. So I'm not going to start there. That tells me I can't really start there. I don't really know how those are related. But what I do know is that the 72 degree angle is vertical to angle 6. So we're going to start there. We're going to say, okay, well, 72 degree angle is vertical to angle 6. So that has to be 72 degrees as well. And then in this bottom group of 4, we have a few more angle relationships that we can work with because angle 6 is supplementary to angle 5, which means angle 5 is going to be 180 minus 72, which would be 108 degrees. Now angle 5 is vertical to angle 4, so I know that angle 4 is also going to be 108 degrees. So now I have 4 out of the 8 angles that I'm going to try to find. And now we can use a lot of different relationships. So a couple of easy ones to use are our same side interior that are supplementary or corresponding angles. So if you wanted to do same side interior, you could do those. So angle 2 and this 72-degree angle, these two here, they're supplementary, right? Or you could note 72 and angle 1 are corresponding. They're in the same position of the 4 angles. So angle 1 has to also be 72 degrees. And angle 2 is supplementary to angle 1, which means it has to be 108. Angle 3 is vertical to angle 1, so that means that has to be 72. Now we can start solving for x. So I know the degree measurement of this angle because it's vertical to angle 2. It's going to be 108 degrees, but I still want to find x. So those two angles here, they're vertical to each other, so we can set their measurements equal to each other. We can say 2x plus 4 is equal to 108. Okay, solving that, 2x is going to equal 104, or x equals 52. And then we found our x value. You can always double check that you did that correctly by substituting back in and confirming that 2 times 52 plus 4 is in fact 108. All right, last example. So when we're doing this, we often want to identify what are our parallel lines and what are our transversals. So we have two different sets of parallel lines. So these two blue lines and these two red lines. And then those parallel lines also can be transversals to another set of parallel lines. So we have quite a few things going on in this picture, but the only transversal that's also not a set of parallel lines is this green one right here. So we're going to go ahead and use our different relationships and work our way piecemeal through this. So there's a lot of things going on here. You just kind of need to pick a spot and go for it. So when you're doing this, make sure that the spot that you pick the angles have the same variable in them. So down here on the left, we can't quite start here because one has an x and one has a y. So we need some more information before we can start working with that. But I can look over here. So these red parallel lines are cut by this blue transversal right here to create our two sets of 4 angles and their relationship. So I'm going to fill in some pieces of this puzzle. So the 45-degree angle and angle 3 are corresponding angles, which means they are congruent. So angle 3 must be 45 degrees as well. Then angle 4 is supplementary to angle 3. So that means it has to be 135 degrees. So we're filling in pieces of our puzzle as we go. Okay, now I'm going to go over into this section over here. So these two red parallel lines cut by the green transversal. And I'm going to start by using this 121 degrees to migrate some numbers over to my expression so I can help solve for x and y. Okay, so first thing I'm going to say is, okay, this expression with x and the 121 degrees, those are same side exterior angles. And what we know about same side exterior angles is that they are supplementary. So I'm going to go ahead and add them together and set them equal to 180 degrees. And I'm going to use that in order to solve for x. So I find that x equals 19 here. And I can use that to substitute back in and find that angle measurement. So 3 times 19 plus 2 is 59. Okay. Now I have a little bit more to work with to find the y with the 5y plus 1. So I kind of have two options here. First option, 5y plus 1 and the 121-degree angle are alternate exterior angles. That means that they will be congruent. Or 5y plus 1 is supplementary to that 59-degree angle that we just found there. So we have two different equations that we could set up. I'm going to work with the congruent. So I'm going to say 5y plus 1 needs to equal 121 because those are congruent. And we're going to use that to solve for y. And we find that y equals 24. Okay, we could substitute that back in, but we should already know the degree measurement of that angle because it is congruent, which means it has to be 121 degrees. Okay, last piece of this puzzle. We're going to go over into the upper right and we're going to start working over here. So this time we have our two blue parallel lines cut by our green transversal. Okay, so we're going to just start filling things in. The 118-degree angle is going to be complementary to angle 2 here because they are alternate exterior angles. So, I didn't mean complementary. I meant congruent. Sorry, I think I said complementary, which is describing two angles that add up to 90 degrees, which is not the situation here. They are congruent. So that means angle 2 is going to be 118 degrees as well. Then we know that angle 2 is supplementary to angle 1. So angle 1 is going to be 180 degrees minus 118 degrees, or 62 degrees. Last but not least, we can solve for z by noting that angle 1 and the angle with the 6z minus 5 expression are vertical and are therefore congruent. So we can say 6z minus 5 is equal to 62, and we can solve. And we do get a fraction, but that's okay. Just leave it as a fraction. Don't round that decimal. We want to leave it as a fraction for an exact value. Fractions happen. Not all measurements are perfect. So we have our 3 variables and all of the named angles or numbered angles found in the picture.